I first reviewed the Waterdrop G3P800 about 3 years ago. Since then, my testing process has gotten a whole lot more involved, and I've now put it through my full battery of updated tests, including 2 brand new third-party lab tests. So this is the complete updated review with way more data and hands-on insights than the first time around. The marketing for the G3P800 looks great. It claims a super fast filtration rate of 800 gallons per day, holds official certifications across 4 NSF standards, and runs at an efficiency ratio that puts most undersink ROs to shame. But it also costs $1,000 and doesn't include a remineralization filter by default. In this video, I'll walk you through everything I've learned about this system over the past 3 years, my updated lab data with and without the optional remineralization filter, all my hands-on field testing, and whether this thing actually earns its premium price tag here in 2026. The G3P800 is a tankless undersink reverse osmosis system, which means there's no bulky pressure tank taking up space in your cabinet. It filters water on demand, sending purified water straight to a dedicated faucet at your kitchen sink. The whole unit measures just 5.67 inches across, so it's actually one of the more compact undersink RO systems on the market. It's best suited for homeowners who want fast, on-demand purified water from a dedicated faucet, are okay with a more involved install, and don't want to mess with manually filling a countertop unit. If you're renting, can't drill into your countertop or sink drain, or want something that's plug and play, this system isn't right for you. If that's the case for you, check the description where I'll link to my video about the best countertop reverse osmosis systems, which are likely a better fit. So at the time of recording here in June 2026, the Waterdrop G3P800 sits at the higher end of the undersink RO market with a $999 upfront price. That's a steep upfront investment, there is no doubt about that, but here's where it gets interesting. When you divide the cost of the replacement filters by their rated capacities and add them all together, this system purifies water for just 11 cents per gallon without the Riemann filter and 14 cents per gallon with it. That works out to about $124 per year in filter replacements and a 5-year total ownership cost of around $1,623. That's one of the lowest ongoing filter costs of any undersink RO I've tested. So while the upfront price is quite high, the long-term cost is actually really competitive. Just keep in mind that filter capacity ratings assume average water quality and usage. If your source water has higher levels of contaminants or you're using a lot more water than average, your filters will get used up quicker and need replacing more frequently. It's also worth mentioning that Waterdrop runs sales pretty regularly, so I'll drop a link in the description so you can see what kind of discount is currently available. So how does the G3P800 actually work? Cold water from your supply line gets pushed through 3 filtration stages. The first is a combined sediment and carbon block pre-filter that catches particulates and protects the RO membrane from the disinfectant chemical like chlorine. The second is an activated carbon coconut filter that further reduces tastes, odors, any chlorine that made it through the first stage, as well as a range of other organic chemicals. And the third stage is the semi-permeable RO membrane, which is where the heavy lifting happens. The RO membrane rejects dissolved contaminants down to 0.0001 microns, which is small enough to remove things like fluoride, lead, arsenic, and PFAS. The system also includes an external UV sterilizer that Waterdrop claims has a 99.9% sterilization rate, which provides an additional layer of protection when the filtered water leaves the unit. Just to be clear though, this UV is not intended to make biologically unsafe water safe to drink. It's there to protect against any bacterial growth inside the system, not to disinfect untreated source water. Now, there are actually 2 models in the G3 lineup. The G3P600 has a 600 gallons per day production rate, while the G3P800 P800 has the higher 800 gallons per day rate. Both use the same filter tech, the only difference is how fast they can produce water. I tested the P800, but everything I'm covering in this video applies to the P600 as well, just at a slightly slower flow rate. In terms of features, the smart faucet has a built-in TDS readout and filter life tracker, and there are additional digital trackers for both of these on the body of the unit too. So you can verify performance and know when filters need replacing without doing any manual tracking. One thing worth noting is that the base model does not include a remineralization filter. If you want to add minerals back to the water for pH and alkalinity, you'll need to buy Waterdrop's optional inline remin filter separately for around $30 and install it downstream of the main unit on the dedicated faucet water line. For this review, I ran the G3P800 through my full testing battery. I sent before and after samples to TapScore for full lab analysis, including a sample taken without the remineralization filter and a separate sample taken with the remin filter installed downstream, so I could show you exactly how the data changes and what minerals are added back in. I measured TDS, pH, and chlorine on site using my own handheld meters. I timed flow rate using video footage frame by frame for millisecond precision. I measured efficiency ratio at both a small 12-ounce draw and a larger 64-ounce draw to see how performance changes as the system stabilizes. I checked TDS Creep after letting the system sit idle overnight. I measured noise during operation at 1 foot and 3 feet from the unit, and I calculated energy usage and cost based on the system's draw and the most recent US national average electricity rate. So if you appreciate this kind of in-depth data-driven testing, give this video a like to let me know I should keep doing more of these, and subscribe to the channel so you don't miss out on the next one. Like all under-sink RO systems, installation is very involved. For me, it took about 2 hours from start to finish, including filming. As a confident DIYer, you can probably knock it out in about 90 minutes. If this is your first time installing one of these, expect closer to 3 or more hours. You're tying into your cold water line, drilling a hole in your countertop or sink for the dedicated faucet, drilling into your drain for the wastewater line, and routing tubing throughout the cabinet. If you happen to have an existing soap dispenser or hole in your countertop, you can repurpose that for the faucet and skip the drilling step. I also highly recommend using a disposal drain adapter instead of the included traditional drain saddle if you have a garbage disposal with a dishwasher inlet. It avoids drilling into your sink drain entirely, which makes the install much quicker and easier. I'll link to the one that I used down in the description. What I really liked about the G3 specifically is the attention to detail in the install kit. Waterdrop includes a pipe cutting tool, the feed line is already connected to the cold water shutoff valve out of the box, and the tubing has markings showing exactly how far it needs to be inserted to seat properly. Little touches like these make a real difference if you're new to this. I also counted only 9 external leak points at the fittings on the standalone install, or 11 if you add the remineralization filter. That's actually the fewest of any under-sink RO I've tested, and fewer leak points means fewer opportunities for things to go wrong. After install, the initial flush took only 35 minutes, which is one of the shortest startup times I've seen on an under-sink RO. So overall, while the install is still time-consuming and not beginner-friendly, the G3 makes the process noticeably easier than other under-sink ROs I've tested. Speed of filtration is where the G3P800 really shines. I timed how long it took to fill 12 ounces of purified water from the dedicated faucet, repeating the test multiple times for accuracy. The average fill time came out to 9.14 seconds, which translates to 0.62 gallons per minute. That works out to about 886 gallons per day under my test conditions, which actually exceeds Waterdrop's claimed 800 GPD rating. To put that in perspective, this is the fastest under-sink RO I've tested so far. There's no waiting for a tank to fill up, you just turn on the faucet and you've got purified water immediately. The system uses an internal pump to provide the required pressure to achieve this flow rate. The other thing the system does really well with is efficiency. Waterdrop claims a 3:1 pure to wastewater ratio, meaning for every 3 gallons of purified water, only 1 gallon goes down the drain. To verify this, I ran my standard 2-part efficiency test. First, I measured the wastewater produced when dispensing a small 12-ounce draw of purified water. The G3 produced 8 ounces of wastewater for 12 ounces of purified water, which works out to a 1.5:1 pure to drain ratio, or about 60% recovery. Then I repeated the test with a larger 64-ounce draw. This time, the system produced just 29 ounces of wastewater for 64 ounces purified, which is even better at a 2.21:1 ratio, or 68.8% recovery. So why is the larger draw more efficient? It comes down to membrane back pressure. When the system has been sitting idle and you first turn it on, the water on both sides of the membrane has to be equalized. It takes a moment for the membrane to ramp up to full operating differential pressure, and during that ramp up period, more water goes down the drain relative to what gets purified. A small draw captures mostly the less efficient startup period, while a larger draw gives the system more time to stabilize at its more efficient operating state. Either way, both numbers are excellent. For comparison, most conventional under-sink RO systems operate at 1:3 or even 1:4 or worse, meaning that they waste 3 or 4 gallons or more just to purify one. The G3P800 is in a completely different league when it comes to reducing the amount of wastewater produced. Now, there's one more thing that I want to be transparent about that affects real-world efficiency, and that's the system's automatic flushing cycles. The G3P800 has 4 different automatic flushes that aren't captured in my draw-based efficiency tests because they happen on a timer rather than during normal water dispensing. First, there's a 20-second flush triggered after every cumulative 2 hours of use, which sends about 52 ounces of water to the drain. Second, there's another 20-second flush after any power outage, which also wastes about 52 ounces. Third, the system runs what Waterdrop calls a circular fresh water flush, 5 minutes after every time the faucet is used, which sends about 28 ounces to drain. And fourth, that same circular flush runs again after 12 hours of non-use, wasting 28 ounces. These automatic flushes are a key reason that TDS Creep is so minimal on this system, since the unit is constantly clearing out stagnant water from the membrane. That is a real benefit for water quality, especially that important first draw of the day. But it's also water that's being sent to the drain in the background, and depending on how often you actually draw water from the faucet, the actual real-world efficiency might be slightly lower than what my draw-based test showed alone. For most households drawing water multiple times a day, the impact is fairly minimal, but it's worth knowing about so you have a complete picture of how the system uses water. Since the G3P800 is a tankless system, it uses an internal pump to push water through the membrane on demand. Based on my measurements, the system uses about 0.004 kilowatt hours per gallon of purified water. To estimate annual electricity cost, I used the most recent US national average electricity rate for 2026, which was 17.65 cents per kilowatt hour back in February. Based on typical household RO usage of about 3 gallons per day, that works out to roughly 77 cents per year in electricity for normal water dispensing. Now, keep in mind that the automatic flushing cycles I mentioned in the previous section also draw a small amount of power because the pump is running during each flush. I haven't measured the exact energy use of each of these additional flush cycles, but Given how short they run, the additional energy cost per year is going to be pennies on the dollar. So while it does use power and a tank-based system technically does not, the operational cost from an electricity standpoint is super low and essentially negligible. Now let's talk about TDS, which stands for Total Dissolved Solids, and is one of the most commonly used measurements for RO performance. Using my on-site handheld TDS meter, my baseline feed water came in at 656 ppm. After running through the G3, the first draw of purified water measured 67 ppm, and after letting it run for about 2 minutes, the lowest stable reading dropped to 34 ppm or 43 ppm with the remineralization filter installed. The difference between the first draw and the stable reading is what we call TDS Creep, and for the G3, it came in at just 33 ppm. For some perspective, some of the other tankless RO systems I've tested have had a TDS Creep of over 400 ppm, so 33 ppm is pretty minimal. This is, again, most likely due to the automatic flushing the unit does while it sits idle. Tankless ROs use a built-in pump, which means they make some noise during operation. I measured the noise of the G3P800 using a decibel meter app at 1 foot and 3 feet away from the unit. At about 1 foot, it produced 46.2 decibels, and at 3 feet, it dropped to 43.6 decibels. For some context, that's about as loud as a convection oven or quieter than a normal conversation. It's louder than conventional tank-based RO systems, which operate near silently because they don't have a pump running every time you draw water. All right, now let's get into the actual lab results. For all my filter testing, I use TapScore for third-party lab analysis. I send before and after samples for full chemistry analysis, and I compare the data against the health guideline levels rather than the federal MCL. The HGLs are stricter, more health protective benchmarks, and they're what I prefer for evaluating residential drinking water filters. For this updated G3P800 test, I sent 3 samples total: a baseline tap sample, a post-filtration sample without the remineralization filter, and a separate post-filtration sample with the remin filter installed. In my baseline sample, the lab detected 14 contaminants with potential health effects. These included 3 disinfection byproducts: dibromochloromethane, bromodichloromethane, and bromoform, plus fluoride, uranium, boron, copper, nitrate, strontium, barium, selenium, total chromium, molybdenum, and vanadium. Of those 14, 5 were detected above the health guideline level: the 3 DBPs, fluoride, and uranium. Without the remineralization filter installed, the G3P800 eliminated every contaminant that was above the HGL except fluoride. Fluoride was reduced by 78%, which is solid but not 100%. Still, it brought fluoride down to below the HGL, which is important to note. It also completely removed barium, copper, selenium, molybdenum, vanadium, strontium, and total chromium down to below the reporting limit. Nitrate was reduced by about 75%. And here's where it gets interesting. When I added the optional remineralization filter downstream and tested again, contaminant reduction actually got better in a few key areas. Fluoride was reduced 100% down to below the reporting limit compared to the 78% reduction without the remin filter. Nitrate was also reduced by 100% compared to 75%. And strontium and total chromium were reduced by 97% and 88% respectively. I think it's really interesting that we observed better rates of reduction with the remin filter installed, especially because I took the samples within minutes of each other. Now, I want to call out another finding I think you should know about. In my test with remineralization, 0.24 ppm of nitrite appeared in the filtered water, even though it wasn't detected in the baseline sample at all. Still, this was well below the HGL of 1 ppm, so not a huge concern. Since nitrite wasn't detected in either of the other tests, this suggests it could be coming from the remineralization media itself. However, we'd need to conduct additional specific testing to confirm this hypothesis. For chlorine, my baseline water contained 2.03 ppm, which is normal for chlorinated municipal water. Post-filtration, on-site chlorine testing showed 0 detectable chlorine in both configurations. That's a 100% reduction and exactly what I would expect from a system that uses 2 activated carbon filters and an RO membrane. For overall TDS based on tap score lab data, my baseline water came in at 776 ppm with 247 ppm hardness. The standalone G3 reduced TDS by 95%, down to 35 ppm. With the remineralization filter installed, TDS was reduced by 93%, down to 48 ppm. The slightly higher TDS in the with remin sample is exactly what we'd expect, since the remineralization filter is reintroducing minerals like calcium and magnesium back into the filtered water. And so one of the most useful aspects of this review is being able to compare the lab data with and without the remin filter side by side. All of this data comes from my tap score tests, which is also on my website, which I've linked in the description if you want to see it all in more detail. Let's start with the minerals that contribute to water hardness and pH. Without the remineralization filter, calcium was reduced from the baseline level down to 0.36 ppm, a 99% reduction. With the remin filter, calcium came in at 3.16 ppm, a 95% reduction. So the remin filter is putting about 2.8 ppm of calcium back into the water. Magnesium without the remin filter was reduced to 0, a complete 100% reduction. With the remin filter, magnesium came in at 0.011 ppm, still a 99% reduction. So the remin filter is adding back trace amounts of magnesium, but not a meaningful concentration. Hardness, which is primarily a combined measure of calcium and magnesium, dropped from the baseline 247 ppm down to 0.91 ppm without remin, a 99% reduction. With the remin filter, hardness came in at 8.36 ppm, a 96% reduction. So you're getting back about 7.5 ppm of hardness with the remin filter installed. For sodium, both configurations showed essentially the same result. Without remin, 11 ppm, a 94% reduction. With remin, 10.9 ppm, also a 94% reduction. Same with chloride, which was 7.4 ppm without remin and 6.4 ppm with remin, both around 92% to 93% reduction. And sulfate was reduced to 0 in both configurations. So the remin filter is almost exclusively adding back small amounts of calcium with trace magnesium, which is consistent with how most calcite-based remineralization filters work. Now let's talk about pH and alkalinity, which is where the remin filter has its biggest impact. My baseline water had a pH of 8, which is slightly alkaline. Without the remin filter, post-filtration pH dropped to 7, which is exactly neutral. Alkalinity dropped to 0 without the remin filter. With the remin filter installed, alkalinity was restored back up to 27 ppm. Bicarbonate, which is a major contributor to alkalinity, was reduced to 0 without remin and was restored to 32.8 ppm with remin. Bottom line, the remin filter is doing exactly what it's designed to do. It's not restoring minerals to baseline source water levels, but it is adding traces and it is meaningfully shifting pH and alkalinity back towards where they were before filtration. So if those parameters matter to you, the $30 remin filter is definitely a worthwhile add-on. Now let's talk about certifications, because this is one of the strongest aspects of the G3P800. The system is IATMO certified to 4 NSF ANSI standards. Standard 42 for chlorine, taste, and odor, Standard 53 for PFOA and PFOS, Standard 58 for TDS, fluoride, cadmium, hexavalent chromium, and selenium, and Standard 372 for lead-free materials safety. The P800 specifically is also certified for barium and radium under NSF 58, where the 600 GPD version is not. And here's why these certifications matter. My lab testing only verifies how the system performed with the contaminants present in my water on the day I tested. Third-party performance certifications are independent verification that the system has been tested to meet defined standards across a much wider range of contaminants and is the gold standard for confirming a system actually works as advertised. All right, let's talk about what the Waterdrop G3P800 does well, because there's really a lot I like about this system. First, and most importantly, contaminant reduction performance is excellent. It eliminated every health-related contaminant that was above the HGL in my baseline water and greatly reduced everything else. Second, it's the fastest under-sink RO I've tested, with a measured flow rate that exceeded Waterdrop's 800 GPD claim. Third, the efficiency ratio is exceptional. A pure-to-drain ratio of 2.21 to 1 at the larger draw is far better than most under-sink ROs. Fourth, the system is IATMO certified to 4 different NSF ANSI standards, which provides strong third-party verification of the contaminant reduction claims. Fifth, the cost per gallon at just 11 cents is one of the lowest of any RO system I've tested. Sixth, the TDS creep was minimal at just 33 ppm thanks to the automated flushing the system performs. Seventh, the install was one of the easiest under-sink RO installs I've done so far, with the fewest leak points and several thoughtful design touches. And eighth, the optional Riemann filter does exactly what it's designed to do for restoring pH and adding trace minerals. Now for the drawbacks, because of course no system is perfect. First, the upfront cost of $999 is high, even though the long-term cost per gallon is low. Second, there's no built-in remineralization filter. If you want minerals added back to your water, you have to buy and install a separate $30 inline filter, which adds complexity and 2 additional leak points. Third, boron reduction is weak at just 19%. Though, to be fair, this is an inherent limitation of RO membranes and not specific to this system. Fourth, the nitrite anomaly in my with Riemann test is something to note. Fifth, the system is louder than tank-based ROs because of the built-in pump. It's not disruptive, but it is audible. And sixth, Waterdrop's 1-year warranty is shorter, especially for this price point. Now let's break down how the Waterdrop G3P800 earned its 9.21 out of 10 overall in my data-driven scoring system. For contaminant reduction, it scored a 9.28. This was driven by strong performance in my lab testing, combined with extensive third-party certification coverage across NSF standards 42, 53, and 58. For filtration rate, it scored a perfect 10. The measured flow rate of 0.62 gallons per minute and the on-demand tankless design make this the fastest under-sink RO I've tested. In design, it scored a 9.7. Component quality is excellent, with NSF 372 lead-free certification, food-safe plastics, plus thoughtful smart features like the integrated TDS meter and filter life tracking. For setup, it scored a 7. This is the lowest category score for the G3, which is normal for any under-sink RO since installation requires drilling, plumbing connections, and routing tubing under your sink. Even though the G3's install is easier than most other under-sink ROs, it's still a multi-hour job that requires basic plumbing skills. For maintenance, it scored a perfect 10. Filter changes are tool-free, the system tracks filter life automatically, and the cost per gallon at 11 cents is among the lowest I've seen. For company policies, it scored an 8.65. The 1-year warranty is shorter than what some competitors offer. Free economy shipping is available to most US states, and the 30-day return window requires that you cover return shipping costs. When you weight all of those category scores together, the Waterdrop G3P800 lands at an overall 9.21 out of 10, making it the highest scoring under-sink tankless reverse osmosis system I've tested so far. So is the Waterdrop G3P800 worth almost $1,000? Based on my testing and scoring system, the answer is yes for the right buyer. If you own your home, can install an under-sink system, and you want fast, on-demand purified water with strong contaminant reduction, low ongoing costs, and excellent third-party certifications, this is currently the best tankless undersink RO I've tested. The combination of measured 886 GPD flow rate, 11 cents per gallon ownership cost, and IATMO certification across 4 NSF standards is hard to beat at any price point. If you want the absolute highest contaminant reduction performance with the most extensive certifications, AquaTrue is still the top performer in my scoring system overall. The G3P800 is what I'd choose for a busy household that needs fast, filtered water on demand without manually filling tanks. If you're renting, can't drill into your countertop or sink drain, or want to avoid the complexity of an undersink install entirely, you'd be better off with a countertop RO system like the AquaTrue. If you want to see how the G3P800 stacks up against the other undersink ROs I've tested, stick around and watch the next video coming up right now. Click or tap to keep watching.